think it's about time to start. Good afternoon. I think this is the last session of the day. My name is Rabih Bashroush, and I'm joined with my colleagues Svet and Davide. I will introduce shortly. In this last session, the way we're going to run this, we're going to start by giving some introduction about some background information about some of the work that's currently being done at the European Commission on legislation and other activities. And then we're going to run a panel session, so it'll be open for discussions. So we'll spend around 30 minutes doing 3 short presentations to give you the context and background for the work that's currently happening, and then it'll be more an interactive session. So may I ask my colleagues Davide and Svet to join me here for the session. My name is Rabih. I'm the coordinator of a European Commission-funded project called Eureka that ran over the last 3 years that looked at ways to increase energy efficiency in European public sector data centers, energy efficiency and sustainability of public sector data centers. So we worked with around 350, 360 public sector data centers in Europe, and we gathered a lot of information, and I'll be sharing with you some of that information. So we start with, I'll be giving you a little bit of information and some background data about the state of the EU data center sector based on our findings from the Eureka project. Then my colleague Davide will tell you a little bit about the eco-design regulation on servers and data storage products. How many of you have heard of the eco-design legislation? Very few hands. Interesting. Yeah. And then my colleague Svet will talk about other wider EU initiatives towards digital and sustainable society in Europe to provide us with a wider context. And then we'll spend the second half of this session on a panel discussion that I'll moderate. So the context. A few years ago, we ran a project called PEDCAT, as well sponsored by the European Commission, that calculated the energy consumption of data centers in Europe, and that was approximated to be around 104 terawatt hours per year. That's in 2014. Recently, under the Eureka project, which is again is a European-funded initiative, we calculated this figure to be around 130 terawatt hours per year. So over a 3-year duration, the increase in energy consumption in data centers in Europe was around 25%. Actually, this is in line with what was reported by Microsoft and Amazon for the same time period. I think Amazon reported doubling in energy consumption of their cloud, and Microsoft reported on 50% increase, so around the same timeline. The 130 terawatt hours, I think, accounts for around 4% of electricity consumption in Europe. So this is quite significant. So, so digging deeper into the data set we've collected from all these data centers we worked with, we figured out that 80% of the data center market is actually data centers that has 25 or less racks. Only 17% has 25 to 125 racks, and only 3% of data centers out there have more than 125 racks. If you assume a 4K kilowatt per rack, so if you do 4 times 25, that's around 100 kilowatt load, around 500 kilowatt load, and more than 500 kilowatt load. So that was actually a revealing figure that the majority of the facilities out there are actually the small size of things. Another interesting figure was on the breakdown, because the data centers we worked with, we kind of looked on we had a list of what the installed base, what servers, networking equipment, storage equipment they had installed. 65% of energy consumption in these facilities was down from the IT side of things. 65% was due to servers, compute, 25% was storage, and 10% was networking. This is the average overall. Of course, you have some telecom data centers that obviously will have more networking, but overall, 65% of IT power can be attributed to compute. and 25% networking. Interesting, in the morning, I think there was a presentation from IHS Markit And they said that the OCP market now, the sale figures for servers actually stands around 65%, and networking is around 10%. It's interesting that it actually maps to the market share of compute and storage and networking. Power usage effectiveness, PUE. How many of you know what PUE is? Oh, everybody, of course, yeah. It's a very important KPI. PUE basically tells us for every kilowatt hour used by IT, how much is used by the facility. Interesting that among the data centers we visited and looked at, PUEs varied between 1.5 and the bulk, if you look at the Bell distribution, the bulk was between 1.5 and actually 7. Yeah? With an average of 2.2. That was an interesting one. And the 7, what do you think, what kind of data center that was? Well, it wasn't, there are few of them. Government, but like what kind of government data center? Yeah, government alone wouldn't cut it. Yeah, that gets you almost there, yeah. Did you say something? Server rooms. So we notice, obviously, the bigger the facilities, economies of scale, the more you get to the 1.5. 1.5 actually were like running co-location, etc. The 7 were either very small server rooms or, interestingly, state-of-the-art large facilities with very little IT in them. Yeah, so this tells us how effective the PUE KPI is and tell us the full story. It tells us a lot of things, actually. We might come to that when we're doing the panel discussion. Another very revealing figure. So in the data set we studied, we noticed that if you look at the middle pie, 40% of the kit installed out there at the moment is older than 5 years old. Yeah, so 40% of the kit out there is more than 5 years old. That kit consumed 66% of the energy and provided 7% of the compute power. That's the scale of waste. Yeah, which there's no way you could see any of that through PUE, for example. So 40% basically, if you switch 40% of your IT kit, you'll only use 7% of your compute capacity. That will impact utilization, but that will be my next point. So we looked at a very interesting exercise. I mean, this is published. You can see the link is there. I think that you'll have access to the slides. You could see the full study. We looked at the same workload. We took a workload, and we looked at its energy consumption in different deployment scenarios. So if you look at the vertical columns are hardwares and servers of different age. Hardware one, like 7.5-year-old kit, hardware to a 6-year-old kit until current kit. I mean, we concluded this in 2016. And then the rows are different deployment scenarios. You look at like on-premise scenario, best case, worst case. We look at PUEs and utilization level, server utilization level. If you look at the top corner for that same workload, if it's deployed on a 7.5-year-old server kit at 5% utilization in a data center with PUE of 3, which is a very, very realistic scenario given the data I just shown you, that workload will consume 51 gigawatt hours. If for the same workload, you just refresh the servers to current ones, the consumption drops from 51 gigawatts to 2 gigawatt hours. Again, completely unidentifiable through just looking at KPIs such as PUE. Massive waste of energy. If you increase utilization as well, there's massive opportunity to be had there. There's a trick about utilization. The increasing utilization is a very interesting area, but it's difficult to do. I'll come to that in a second. Speaking of utilization, again, looking at the data set, we noticed that on average, the utilization levels varied in data centers between 15% to 25%. The bulk average is 20%. There were exceptions, some exceptions around the 30%, and when you go to hyperscalers, who are like minor part of the pie, they go up to 50% and a little bit higher because of various reasons I'll come to in the next slide. But the majority of the market is 15 to 25%, an average in the market 20%. Another study came just after ours from the US, from Berkeley, by Jonathan Kumi and Arman Shiabi from LNBL, and about the state of the US data centers. And their study showed an average utilization of 20%, more or less exactly what we've got here. And their prediction is by 2020, that average utilization will go up to 25% or something. Now, why is it difficult to increase utilization level? Obviously, there's massive opportunity there, but it's not easy. One of the reasons is if you run active-active deployments. So if you have active-active, to cater for resilience, then you're limited to 50% utilization to enable the workload to go to the other node. Or if you have peak utilization versus performance. Some architectures, they tell you we cannot guarantee performance above 70 or 80%. Or if you want to ensure there's enough capacity in the system to cater for workload peaks. Various other, or if you have wrong server configuration, if you have not enough memory, then you'll saturate the memory and leave the CPU underutilized. So there are various challenges to increasing server utilization. I think this is a good point where I'll stop and allow my colleague Davide to speak about eco-design legislation. Thanks very much.
Thank you, Rabih. Thanks for inviting, and good afternoon. My name is Davide Polverini. I work in the European Commission on the implementation of the Eco-Design Directive. And the aim of this session is basically to update you a bit with information on upcoming relevant legislation for servers and data storage products. And we have a case here which I think is worth of interest, basically an upcoming eco-design regulation, as I said, on servers and data storage products. I saw before when Rabih was asking that some of you are aware of what eco-design is, not the whole of you, so I will make a brief introduction. I promise I will not be long and boring. But we are in the context of what? Of the European Union policy in the context of the environmental impact of products. This is one part of the European Union legislation, and the presentation from my colleague Svet afterwards will give a broader view. But again, specifically at product level, we typically have 4 legislative tools which we use. Please take it as a very, very qualitative graph, so nothing quantitative, but if we could ideally put on a graph on the y-axis, number of products on the market, and on the x-axis, their sustainability, whatever it means, what we see is that, according to this classification, we have a first legislative tool, which is eco-design. Eco-design regulations basically impose typically minimum threshold requirements, which can cut out the least sustainable products from the market, the worst performers from the market. This is valid for everything. It will be for servers. There are already eco-design regulations for basically all the products which you have in your house, in your apartment, of big, middle size, so refrigerators, oven, dishwashers, washing machines. They are already impacted by eco-design regulations, again at European Union level. We then have eco-design with mandatory minimum requirements. We then have another important legislative tool, which is the energy label, which is really meant to foster a transition of the market towards a higher efficiency, typically energy efficiency, but in general towards a higher sustainability. You may already be aware of the energy label because every time you go, again in the European Union, in a shopping mall and you want to buy a washing machine, a dishwasher, you should find the energy label on it. So this A to B, green to red scale, giving information on the energy performance of the energy efficiency of the product. I said you should, well, you must find it. Otherwise, it's a case of non-compliance. We then have 2 other legislative tools, which are really meant to encourage the development of the best performance in the context of product sustainability. The GPP, the so-called Green Public Procurement Criteria, which are developed by the European Commission for usage by the relevant national and local public administration authorities of the European Union member states. And then we have Eco-Label. The Eco-Label scheme is again meant to really identify the best performers of the market of a certain product group, not only in terms of energy efficiency, but in general with a wide set of criteria addressing all the environmental parameters. The big difference between two of these tools and two others is the following one. Eco-design and energy labeling are compulsory. It means that whenever we have an eco-design and or an energy labeling regulation which is valid in the European Union, every product which has to be placed on the European market has to be subject to these regulations. On the contrary, the participation to the green public procurement criteria and to the eco-label scheme is voluntary. So it is really left to the manufacturer who want to show the good or best performance of their products, but it's voluntary. This said, let's again talk specifically about this upcoming eco-design regulation. So it will be an eco-design regulation which will supposedly cut off the best performance from the market in terms of products for servers and data storage products. Let's not also forget that there is ongoing work also on other tools, because there are some colleagues of mine also working on green public procurement criteria for data centers, but it's a bit behind and will come in the next months. So this eco-design regulation, I will not bore you with the details, but basically it's close to its finalization. It has been recently, it is 2 weeks ago basically, voted by the European Union member states. This is an important procedural step, and the finalization of this process will be when this regulation, as every other regulation of the EU, will be published on the official journal of the European Union. As of that moment, it will become legally binding. The proposed requirements under this regulation are, I would say, quite an extensive set of requirements, both covering and addressing the aspects of energy efficiency and material efficiency to promote a circular economy. The proposed approach is to make this requirement compulsory as of March 2020. There are, for the energy efficiency aspects, requirements, these are for the servers, for their maximum idle power consumption. So there's a cap, depending on the product configuration and features, on their idle power consumption. There are requirements on their minimum efficiency in active state, because we also developed a metric to this extent. For those of you which may be familiar with, this metric is based on the CERT testing protocol by SPEC. We imposed minimum efficiency requirements for the power supply unit. And there will be also information requirements on the product operating conditions. Again, for those of you who are acquainted with, based on the ASHRAE data center classifications of operating conditions, the A1, A2, A3 scale. And we also impose idle reporting requirement on the idle power consumption at higher temperature. We also have requirements on material efficiency aspects. This is already another big discussion. Just to tell you that we acknowledge, we recognize that servers and data storage products, as an example, when compared to other domestic products, are already show already good examples of refurbishment practices, take-back schemes. So they are already good pupils in the matter material efficiency. What we think is that the proposed requirements can further improve the circular economy of these products in a way which is fully sustainable for business. And basically, we foresee a set of 4 requirements. A requirement on disassemblability for certain relevant components of the servers, basically the ones which are deemed to be important for their repairability, such as the CPU, battery, and other components. We impose a requirement on the compulsory presence on the product or with the product, so with a USB or with a CD, of a secure data deletion functionality, which could be a software or something else, to basically foster the reuse of the data storage components of the hard disks. We want to propose that basically the firmware updates for the product are available for repairers to foster this market. And to finalize, we also have a requirement to foster recyclability, to compulsorily inform those who buy servers on the presence and the weight range of 2 critical raw materials, the neodymium in the hard disks and the cobalt in batteries. So these are the 4 requirements for the products under this eco-design regulation, which have to be coupled with the energy efficiency requirements, which we have seen in the previous slide, again on idle power consumption, or minimum efficiency of a power supply unit, and the information requirements. I just close showing you very rapidly which are the products affected, which will be affected by this regulation. Servers with up to 4 processor sockets, so rack servers, blade servers, multi-node servers. Please note that it's not that every product subcategory has exactly the same requirements. There are some differentiations, but I wouldn't go into the detail on this. And the online 2, 3, and 4 data storage products. This is taken from the SNIA Emerald taxonomy. So, in essence, this is the content of this eco-design regulation, which again is quite close to finalization, with the idea of having this requirement coming into application as of March 2020. Thank you.
Okay, good afternoon. Let me up in the wrong direction. So my name is Svetoslav Mihaylov, and I'm working in DG Connect within the European Commission. DG Connect is dealing with the ICT aspect, so networks, IT equipment, and so on. And nevertheless, even though I'm working there, and of course, the IT equipment is and jobs, etc., are our goals. My unit particular, which is Smart Mobility and Living, is busy with sustainability. So we're focusing on sustainability. Therefore, there is the kind of the 2 things that are coming together, and you will see how they're coming together. And therefore, this is the unit with DG Connect that is dealing with sustainable ICT and sustainable data centers. As such, I mean, our goals are, like several other services at the Commission and the EU as a whole, the sustainability goals of the Union, which are, they stem from the Paris Agreement and the EU sustainability objectives. The cloud as such is a very cross-border phenomenon, so that's why the European Commission is looking into this, because it's not particular for a country or something. And then there are sustainability development goals. Now, the targets of the EU, I don't know how familiar you are with them, but they're targets for different years as they're coming. So there are targets for 2020, which we are already there, but they were put already many years ago. Then we have 2030 and 2050. They're ever increasing in their ambition, reaching, like in 2050, you see the greenhouse gas emissions should be almost eliminated, especially in the energy sector eliminated, and the rest of the sectors almost eliminated. And the rest goes for, the same goes for the renewable energy that goes from 20% almost to 100% by 2050. Depending on, again, on the area of the sector and the ambition. And then the improvement in energy efficiency, the same thing, it's improving. Also, the ambition is increasing with the years, not only because of the different targets, but if you see one of the targets, for example, 2030, recently, the ambition there was increased from 27 to 35% by the European Parliament, so we are kind of pushing it forward. And therefore, of course, we have to be more ambitious into achieving it. The other aspect that we have to look at that is influencing the thing is the development of technologies, which are allowing us to do more than we could do before. So if you look like microelectronics, this is improving on a grand scale, and you know how the processors are improving, I don't have to tell you. Software, same thing. We have gone long way. And then 5G, so okay, connectivity, the 4G, advanced, et cetera. So from there, we're going to 5G and so on. So connectivity in general is improving by leaps and bounds. If we take these kind of initial basic components, then we can go into some other technologies that depend on them and that are enabled by the very availability of an improvement in these areas, such as, robotics, artificial intelligence, big data, cloud, and then the Internet of Things. These are still, again, kind of mid-complexity technologies in order to address the real problematic, to create the real applications, to solve societal challenges, and so on and so on. And the societal challenge that we're discussing now, of course, sustainability, so energy efficiency, greenhouse gas emissions, and so on. How do we address them? And this is where my unit comes into the picture, is by having smart cities, smart energy, autonomous driving, which is also smart driving in a way, smart homes, smart water, you name it. They're all enabled by these different technologies. Because our goal is, I know we are discussing here data centers, OCP and so on, but we're trying to address with digital the other areas as well. So using digital in order to solve the problems of the other areas. What is needed for this to work when we are in the digital area is a bit the same like with OCP and other initiatives that we have. It needs to be interoperable. I mean, it needs to be one needs to understand the other, etc. So to be able to make equipment that can be ripped and replaced, that can talk to another equipment from another vendor and so on, to avoid vendor lock-in and so on. The same, what is the goal behind OCP to a great extent, the same is valid for all these smart technologies that we're introducing in order to solve the sustainability of the other sectors. And there, for example, the different layers of interoperability that we see. So there are the so-called platforms, which is kind of a software layer that is integrate all the different data coming from, in this case, smart cities that I'll describe, but also can be coming from the energy sector, from the automotive sector, and so on, coming into the platform, then being stored, processed, and then exposed via standardized APIs to the application vendors. And all this needs to be standardized because, as I said, it's going to be cheaper, replaceable, and so on, replicatable, and so on and so on. The same what happened in the telecom sector with the GSM standard, the same what OCP is doing in the data center field, the same is happening in the smart area. So there we put together the stakeholders to work within the European Innovation Partnership with Smart Cities and Communities to develop, this was common initiatives between us and the stakeholders, to develop the platform for the smart cities, so the urban platform, kind of the blueprint for it, not the physical one. There we had two groups, 110 cities, and then 93 industry players to work on this. In the cities, they were led by London, and we have all the big cities in Europe involved into this. And then on the industry side, it was led by SAP, but we had also Microsoft and all these like Huawei's and these kind of companies. Also energy companies, Alliander, BMW, then Volkswagen via SEAT, etc. was participating, and then Bosch and Continental, that are behind the automotive sector, and so on and so on. I mean, full scale, because here we're talking smart cities, not only the digital stakeholders, but also the other stakeholders that are involved. And there was also Horizon 2020 creation support actions to help them. So they came up with these blueprints, which became a DIN standard, and now they're being brought to ITU. They're being adopted and becoming standards of ITU, IEC, ISO, etc. 1M, 2M, of course, because ITU and 1M, 2M are talking to each other and transposing each other legislation. And the idea is, target is by 2025 to ensure 300 million citizens of the EU are covered by these data platforms. What will they allow? I mean, they will allow that we can have cross-sector applications, such as, for example, I don't know, if there is a problem on the grid, then maybe the autonomous driving system will steer the electric cars in order to go to a charging station, in either to consume the extra energy that is available or to give to the grid in order to balance it, because there is a shortage of electricity in the system. This is just a very simplistic one, but you can put it in any direction with any of these sectors. So this is for the platforms, and then the other layer of interoperability is the ontologies, so the semantic interoperability, where we initially started with a big group of stakeholders in a fast-track procedure to create a standard for this ontology for the smart appliances within the home. With the same idea, you can take in and out any appliance. You can buy a washing machine from Bosch, and then, I don't know, a dishwasher from Miele, and a Samsung vacuum cleaner or whatever, anything that can be connected in one way or another to the energy system of the home. Without mix and match, without having to stick with only, like Apple products because it's such an ecosystem or something. And then this was done by the European Commission study and then standardized by Smart M2M of ETSI and becoming a 1M2M standards. Now, 1M2M is the global organizations for standardizing the Internet of Things. This happened in 2015, the standardization. And then commercial products have been on the market since 2016. Then the concept was so successful and well accepted by the market and stakeholders. So we extended it with all the other areas, such as, already for energy buildings and environments that were existing since the beginning of the second stage, when we had a modular ontology. And then we started adding smart cities, smart agri-food, industry, manufacturers, automotive, health, aging, water, wearables. So it's essentially the Internet of Things ontology. So semantic interoperability. And then that's very good. So this will solve or improve the emissions of the different sectors: automotive, energy, water, health, you name it. But this means we are stimulating the deployment of a big amount of ICT equipment and infrastructure. This is not coming free in respect to energy consumption and the environmental impact. So we said, okay, we don't want to push into something at the end of which we're going to have the same amount of emissions, the same amount of energy consumption. So then we have to make sure that what we're adding as ICT infrastructure is not adding nearly as much energy consumption and environmental impact as what we are removing from the other sectors. And therefore, we already for many years, we have been looking at particularly the data centers, but of course the whole ICT sector, what the situation is, how we can improve it, what we can do about it. We have had a number of studies. I'm not going to present concrete results because the last one was a bit still outdated already, but we're starting a new one soon. We're selecting the vendor, the supplier for this. But so we have had a number of consultations with industry via studies, via workshops, and so on and so on, in order to see what the situation is, what we can do, and so on. Here I have presented how we have used our funding instruments within the framework programs, like FP7, which was the previous work program, the Horizon 2020, the current one, and I'll show you some thoughts of the incoming ones. So we had a number of a whole series of projects that we sponsored, addressing different aspects and then kind of building up on each other during the years. So the first series was like 4 projects that were focusing on individual efficiency of a data centers versus efficiency of a cluster of data centers and so on, for about 12 million total funding for the 4 projects. Then building up on this, we had a call that was focusing on renewables, heat reuse, smart grids for 18 million in total. And there we had 6 projects, which recently finished. And they had some targets like to achieve 80% renewables and so on. And so to integrate with the smart grid, to be able to work as a flexible load and so on and so on. Then we said, okay, we have developed all these things. One thing that we have to do is, in order to kind of stimulate the usage of this, we need to inform. We have some impact on the public procurers. We cannot influence everybody on the market, but on the public procurers, we have quite some impact, and they represent 20% of the total procurement, so really significant market force. And therefore, we sponsored a call where Eureka was the project, which Rabih mentioned, and he was the coordinator, which helped the public procurers to know what's on the market, how they can procure, how they can install, and so on, sustainable equipment, et cetera, et cetera. So kind of preparing them, creating the networks that are needed for this kind of procurement, maybe aggregating demand and so on, these kind of activities. And there was a tool that they developed that the public procurers can use. And then we also, something that I didn't mention, another thing that the Commission is doing, of course, via the GRC is the European Code of Conduct for Data Centers. And when we consulted the market, which is very good, is used by the majority of the big players on the market, but the smaller ones have difficulties using it because when we consulted the market, they said, okay, but some people even have language problems. Sometimes the small companies don't have the knowledge, et cetera. So we created, and there were we also worked on methodologies within ITU, et cetera, methodologies for measuring the impact and so on. And all these things were difficult to take up because of these barriers that I said. So we financed another project, ICT Footprint, that was working to close this gap to these small companies. And then recently now, a couple of other projects started where another action building up on this second wave. One was with the public procurements. Another one is because this was research projects, now how do we take them really up to the market level, TRL 8, 9, et cetera, 7, 8, 9. And there another couple of projects are sponsored for 6 million in total, so 3 million each, more or less, to bring these technologies to the market in the coming years. And then also, these projects were working in a cluster in order to develop common metrics, methodologies for environmental and other impacts, and then bring it into standards. Also benchmarking mechanism of how to define the sustainability of a data center and so on. And then if we take it further, this was kind of the current and the past. If we take it further for the next framework program, which starts from 2021 until 2027, there are several instruments that are being developed. It's still under development, so whatever I tell you might change in one way or another. It's under development, but it's fairly stable already. So there is the normal one, the successor of Horizon 2020 is the Horizon Europe program, the same thing. And there we have foreseen, within the program, it's included a topic on sustainable data centers, where we see a number of projects kind of overlapping each other of innovation action, so something bringing things to the market, and then research action, to research further into what are the other techniques and technologies that we can use. And the moment one research finishes, one innovation action starts. So in order to bring these things to the market and so on. So it's a kind of a rolling mechanism. The budgets are still to be defined. There is 12 billion for digital. How much from this will be for data centers? That's, of course, a small part of it. But then there is the Digital Europe program, which is specifically for digital. There's something separate. And where we are looking into smart cities and, of course, everything around them. So we have a topic project on smart cities. The total budget is 9 billion, but the smart cities, okay, we have requested 2 billion, but this is changing with the time. So there, some things will be addressed because these smart cities have to be developed on digital, and we have to address this as well. There might be some opportunities for data centers there as well. Connected Europe facilities, it's about cross-border deployment. There again, one of the topics that is proposed and that is on the table there is about the cross-border data centers. And for these two topics, we have the Horizon Europe and the Connected Europe facility. We had workshops with some stakeholders. Rabih was there as a moderator, as a rapporteur, to define what can be done there with the stakeholders. And we defined that some things that can be done are like, government cloud, where the governments can share their clouds in order to optimize their networks and so on and so on. So that's another option. And then the fourth one doesn't contain any component that they can share with you that will be interesting for this audience. So I think that's it. So maybe back to Rabih.
Thank you very much, yeah. Thank you. Davide, Marks, yeah. Okay, it's the last session, so everybody's tired. But so questions, before I start about any of the presentations you've seen. So if you see, I'll start with John, and then I'll come to you. John? Mm-hmm.
Which is saying that ICT is going to say a factor of 10 on greenhouse gases. Do we ever talk about that? We always talk about
That's a good point.
Data centers, but we never talk about greening ICT, but we never talk about the greening by ICT.
That's a very good point, John.
So
Yeah.
do we ever look at those? Do we look at those reports that came out of Smart 2020, Smarter 2030? In order to try and leverage better reasons why we're doing the things we're doing. Are they right? And then in my slide I have Bertoldi talking about 104 terawatts by 2020, and you, and let's just say Eureka was talking about 130.
These are two questions. Yeah.
So then we need to understand.
Now I'll come to these 2 points. Yeah.
So one is do we need to understand the energy consumption, and one is about
The figures.
about the greening by ICT.
So so the first one is definitely spot on. Obviously, we completely agree with you. And all the publications we make, myself as a group, and I'm assuming the Commission, they highlight the importance that the IT is playing in greening many sectors like teleworking, transport, etc., etc. I don't think we have precise figures on the savings, but I don't think anyone questions the efficiency created through digitalization projects and automation and so on and so forth. So I think I don't disagree at all with you that given the added value, the greening by IT aspect. However, the energy consumption of IT itself is measured. And as I presented earlier on, I mean, there is an opportunity. So if you look at things like hardware refresh, or installing efficient servers, or increasing utilization, or various aspects that could have substantial impact on the reduction of energy consumption. This brings us to the point about Paolo's figures from the EU Code of Conduct. So this is good you raised this. So when I say, for example, here that the average PUE in Europe is between 1.5 and 7, the bulk of it, and the average figure is 2.2, I think. So this is based on studying 50, 60 data centers across Europe. These are not selective. Paolo's figure, the figures that come from the Code of Conduct, are based on the data set they have access to, which is the figures reported by organizations that are endorsers of the EU Code of Conduct. This is not, so his PUE average is 1.7, but based on that data set. However, that data set is not reflective of the market because this is selective, self-selective, because that data set only contains data centers that applied for the EU Code of Conduct. So basically, they're already applying best practices. So the best of the best, technically, average at 1.7, but the market average at 2.2. And their figure of 104 terawatt hours is based on that database, which is not very reflective. Our figure is largely based on the sector-wide data. So that describes why the slight deficiency. Don't get me started on that front. Don't get me started on the peer review process.
But is it not the case that we're reporting peak power consumption of data centers, and data centers never, put a data center on the planet, you say it's going to consume so many megawatts because that's its peak.
That's not, no. So what we measure is the measured, not the capacity. I think this is the issue. So the one reported as well, people reporting that that's very true. That's very true. And you know, you never go anywhere near the capacity anyway. So, yeah. Especially that, yeah. Thanks, John.
In your presentation, you had a pie chart of data centers greater than 25 racks.
Yeah.
Was the pie chart numbers of sites or was it number of racks?
No, number of sites. That's a good question.
Okay, so like if you have 1,000 racks in your market,
Very true.
how many of those are installed in big data centers versus small? Because that's an important point.
It's a big data set. We can try and run and see if we can answer this. But what I can tell you is that if there are 1,000 data centers out there, 80% of that would be the small, containing 25.
But maybe 80% of the racks are installed in large data centers.
I don't have the answer to that, but could be, yes. Technically, it could be 99% of the racks installed if those have millions of racks, theoretically. But I can get you a figure by looking at the data set and see if we can look at this, yeah.
What's your definition of a data center? You also take into account the enterprise data centers?
So for us, a data center, well, we're not going to contribute a new definition because there are 300 out there and people don't disagree on them. But what we looked at, if you get racks, okay, if it's a server under a desk, it's not a data center for it. Once you get a rack, we looked at it. And the only reason we looked at number of racks, not IT, it's much easier to inspect when we went around the data center. So we looked at rack count rather than anything else. Now, this is...
Also then within companies who have their own server racks in a facility somewhere.
So we looked at those. Yeah, this is all within scope for us. If you got a rack with servers, even if for one rack, that was looked at. Yeah. Now, I don't think we came across one rack. The 3 racks and above, that was the set. But I think this is a very good question because what constitutes a data center is the biggest thing. Because at the moment, that term refers to various beasts, where the co-location is a data center, enterprise is a data center, small server room is a data center, and they're different business models, different technologies, facilities, etc.
Because in the telecom market, there's also a move happening, changing the central offices and the metro co-location to all
Yes.
small data centers. So if you take those into account,
Yes,
thousands of extra sites.
that's true. That's true. Yeah.
Well, other question, if I may. So
Yeah.
what will actually happen now? March 2020, will I still be able to buy the service which I buy today, or will they suddenly stop being sold?
I'll forward this question to David.
Yeah. So, being confirmed that this regulation, which I was showing you, will become European law, and again, this will happen officially when it's published on the official journal of the European Union, and we expect this to happen around next February, so February 2019. This regulation foresees that all the servers and data storage products which are placed on the market as of March the 1st, 2020 onwards, they will be subject to the eco-design requirements laid down in that regulation. Therefore, it means that the manufacturers will have to show compliance of their products against the requirements of the regulation.
But you must already have some idea what will happen. So if you look, if I buy 100 different servers from different parties today, how many will comply with this law? Will we only have 5% left, or will all of them fit if you buy them today? Or?
Thanks for the question, because there were actually big discussions. This is typical in the implementation of eco-design. We do it, I've just shown you the very final result. Actually, we had 2 or 3 supporting studies to derive these requirements. First of all, to define which kind of requirements, to define which level of stringency, and for sure to try to estimate which is the impact on products. Let me also say that eco-design traditionally has been applied to domestic electric products such as washing machines, dishwashers, for which the evolution curve of, let's say, efficiency is several orders of magnitude smaller than the one of the ICT products. This said, our estimates are as such that, let's say, we should see requirement per requirement. But if we take all the products that today are on the market, they are not all compliant with this regulation. If I have to give some figures, and very preliminary one, as an example, the requirement on active state efficiency, this is quite, let me say, lenient. It's just for introduction of the market of this testing methodology. So we don't foresee a big challenge on this. The requirement on idle power, it was really debated a lot with relevant stakeholders, typically under the umbrella of Digital Europe. It's an organization which collects some big companies. And there has been a kind of, sometimes, disagreement in the sense that their estimates were that these idle power requirements will quite heavily affect the market. To say something like 75% of products today would be not compliant with respect to the requirement of idle power for servers. Our understanding is not this one. If one has to draw a picture, is roughly, let me say, 50% of products on the market today with, let me highlight that we are talking about requirements which will enter into force in 2 years. And we had also tried to estimate the pass rate with a specific requirement for product families throughout years, and we could see there was a clear improvement if we would have taken a server of 2013, a server family for 2013, I don't recall, but a significant part of these families would not have been compliant. This is going to reduce if we take the latest families of 2016 and 2017. There are clearly hypotheses behind, but whatever we propose under eco-design is basically something which we deem feasible for a certain product group within the time frame that we give for the other requirements, but also for the others that are in the regulation.
Let me just clarify something, because when you say 50%, that's 50% of servers that are impacted, because you have exclusions, right? So you get the exclusion, so not all servers will have to comply. So servers will, resilient servers.
Yeah.
So that excludes a big part of the market, actually. The reason I'm raising this, because some of the feedback from some players saying that because of all the pressure on the Commission, the regulation at the moment has no teeth. It's so lenient that it doesn't exclude much. So let me clarify that the view on this.
Yeah, our point of view is that we think it's a balanced way, and indeed we have been confronted with position which sometimes are quite opposite from various kind of stakeholders. And again, thanks for this point. Again, coming back to the figures which I was giving for the adult power and servers, it's for the products which are impacted by these requirements, which are the 2 sockets and 4 sockets, and not specific classes like HPC servers, server with auxiliary processor, etc. So it's a specific product group.
Just one question in regards to the implementation, because I understand that there we have regulation to the directive, and then it must be implemented to the local markets, right?
If I understand correctly your question, the specificity of eco-design is that it doesn't need national transposition, in the sense that the day after it's published on the official journal of the European Union, it's European law which gets applied in all the European Union member states. So it will be published around next February, and as of March the 1st, 2020, it will be compulsory for all the servers sold in the EU, with no need of transposition at national level. If I understand correctly your question.
Yes, that was the question. The question refers to the somehow challenge how to impose that law, because right now talking with the customers, with data center customers, which are, those guys are trying to start it, how to go around that directive. So how to make the idle server not idle. Just opening the one Kubernetes, put into this list, and it's not idle anymore, although it's quite like idle. So
Thanks for. Thanks for this question. We're now, clearly there is a word behind eco-design, so in this short time of the presentation, I hadn't the chance to discuss everything, but this is a useful point. We are talking now in this case about market surveillance, which is typically done by national market surveillance authorities on the eco-design regulated products. How it's done? It's done, again, when the products are placed on the market. What does it mean in practical terms? Again, if we take this simple example, maybe simplistic example of washing machines, when they are in the shopping mall on the stores to be sold. This is clearly not happening for servers, because I understand they are not available in shopping malls, but there, the different national market surveillance authorities, they have their techniques. Sometimes, I understand they procure, saying explicitly that they are market surveillance authorities. In other cases, they don't say it explicitly. It changes from country to country. But in general, whatever is done on a product which is not in real operation, but it's done on the product when it's coming.
Point of sale, basically.
At the point of sale, indeed. It's clear that, if I understand correctly your question, the way in which we impose the requirements entails assumption on the real use behavior. Like, yes, for the requirement in adult power, we impose it because we think, and this is in line with the findings of projects like the one of Rabih, that still today a significant share of servers in the EU market are operated at idle power for a significant part of their operational lifetime. On this basis, we impose the eco-design requirement on idle power, which is checked at the moment of placing on the market. As an effect of eco-design, no market surveillance authority will never be empowered to go in a data center and say, this is operated with very high utilization rate. No idle requirement for this other one, yes. No, it's something which is checked at the moment of placing on the market.
So just to make sure that I understand this correctly, then it's about on the supplier side, because the data center operator are going to just buy. They don't go to a shopping mall to buy the server, but it's on the supplier side to make sure
To comply.
From March 2020 with the directive about that it takes into account all the requirements you just mentioned before. It's not on the data center operator side. That's one, which means that it doesn't fall back. It's only on the new products.
New products on the market, right? So so for companies that recycle and then put products on the market, they have to comply, right?
Now we start
It's a tricky area.
a very long discussion. I mean, I'm happy to talk about it, but not very briefly. Let's say it applies on new products, so it's not retroactive, first of all. Second, in legal terms, the responsible is the entity which is placing on the market of the product, which is usually the manufacturer, indeed. It's not the data center manager. If we come to the point of how to deal with refurbished products, I have to become a bit legalistic. Basically, we have a reference document for all the internal market European Union legislation. It's called the Blue Guide. And in very short wording, what it says is that if you take your product, which is the case of a server, you want to repair something to bring it to the starting conditions, as such, the product is not considered new. But as soon as you refurbish it, as an example, to have it more powerful or with more hard disks, in this case, it will be considered a new product. So it depends. Case by case, it also depends on who is the entity placing it on the market. So it's not a straightforward reply.
I got it. Good point.
I'm sorry.
Good point. No, that's a good point. Then.
Yeah, so I mean, more efficient servers is a good thing, but if you take an efficient server and you put in a data center with a PUE of 7, then that's not great. But even 1.7 or 2.2 in 2018 is still pretty depressing. We heard from Norway and from Rackspace this morning, doing 1.2, Facebook manages 1.1, Hyper66 we manage 1.04. So what can we do to drive adoption of lower PUE data centers as well as more efficient servers?
We'll take that one. Or you're going to take that?
If I just make
go
on. On this question, I mean, maybe I was running a bit through the presentation, but we are aware of these aspects. Specifically for the eco-design, it's a regulation at product level, so mainly it will affect the products, the servers and data storage part. However, being aware of this, what we have proposed is to make it compulsory that the manufacturer will have to declare if the product is operational, in which ASHE operating class the product is capable to perform, A1, A2, etc., and also to report the idle power consumption at this higher temperature, with the idea of giving more information to data center managers and operators if they want, as we understand it's feasible, to increase the operating temperature of the products.
So continuing, exactly what I want to say. And remember, this is one intervention and focusing on one element. There are various interventions, as you've seen on the thing. So there's green public procurement criteria coming in because the Commission cannot control what private sector does. And that will impose things like, that will impact the PUE, impact utilization levels, etc. But there is more. So there's a big drive at the moment, and I can see probably from the UK. And we got cloud-first strategy. So to make the facilities we're talking about energy efficient, the small ones, it's not going to work. That's the quick answer. You have to consolidate. You have to shut down these server rooms and consolidate in bigger, more efficient facilities. And there is active work at various levels at the moment to push for this agenda. And we see it happening all the time. I think there's that drive for consolidation. There's the drive for code of conduct and the application of best practices and that kind of. There's the EMAS, there's a BEM, best environmental management practice for data centers. It's not mandatory, but it kind of encourages the uptake of best practices to lower the energy consumption and increase efficiency. So there are various interventions. I don't think this is one of them, and I think it's targeting a key area, targeting basically the idle problem that we have, and I don't think we'll be able to address it. We won't be able to increase utilization anytime in the near future, within the next 5 years at least. I think this is the problem this particular one is addressing. Now, Facebook, etc., runs at 1.1, 1.01. True, but I don't think it's a fair bar to put for colo providers, etc., because it's a different business. And back to the same problem, what constitutes a data center? I know some telecom providers run at 1% utilization, but they've got some business reasons to run in a certain model. I'm not saying this is the right thing to do, but they're different beasts, right? But yeah, this is a very good point. This is alone won't solve the problem, but we need to keep pushing for the other interventions.
No, but there'll be also to say, I mean, legislation for PU, we cannot introduce legislation because this will be gone around, as was mentioned there.
Very difficult
there will
police.
there will be a way around it, and also legislation. This eco-design study took already 5 years or something. You understand? If we start it now, we're going to arrive in 20 whatever when it's not even relevant anymore. So I mean,
Yeah.
Legislation is not the way forward. So if you expect from the Commission to regulate it, first of all, PU
That's
is
another
not
balance.
reliable criteria KPI to use for, and then it takes too long, which is not adapted for this industry. We always prefer to have some kind of agreement, such as the OCP, such as what I mentioned for the platform, etc. And we are ready to help the industry to put them together, you know, convening power with different parties.
good.
This we are ready to do. In extreme cases, we do legislation, but we prefer to avoid because it's not helping anyone.
Very good point. I think I can take one and then two.
Question about certifying equipment for this idle power. A certifying body, and is there going to be a badge that's going to go on equipment so procurement guys know that it is what it says.
Compliant.
Hopefully not, we're going to avoid what's happened with Volkswagen and their diesel.
Can you avoid
okay,
that?
but yeah, no, this.
Again, so how are we going to police this?
Davide?
Thanks for the question. Again, this gives me the chance to go through another part of the eco-design world, showing compliance. Again, referring to the bulk aspect of the EU internal market legislation, we have several approaches to how to show compliance. The directives like eco-design use the principle of self-certification inspected by the national market surveillance authorities. It is then basically up to the manufacturer to choose whatever means he or she wants to show compliance. Typically, I understand that 99% of manufacturers use the so-called harmonized standards. So standards developed at EU level by the European standardization organizations, which give specific methodologies for testing and calculation. And to make you an example, relevant one for our case, there is a standard under finalization by ETSI for the calculation of the server efficiency and the idle power. In practice, it's based on the CERT testing methodology. So it will be up to the manufacturer to choose to report the data because they measure, or they could even go to an external laboratory and to take the documents taken from this laboratory. In any case, it will be the manufacturer who is responsible for the placing on the market, and it will be up to the market surveillance authorities to discriminate and to decide on the compliance of the product and of the specific aspect. But it's in general, for eco-design, we have the principle of self-certification. There is no compulsory certification if I exclude one or two very specific cases like the NOx emissions of heating systems. It's a very specific one. Whereas in 99% of cases, it's self-certification.
Can I take one more question? I think we're running out of time already. So.
I would like to know if there is also a program, eco-design program for data center cooling equipment, like air units, crack units, or something like this. Because we have also products, for example, for hospitals where the eco-design already is applied. But for the data center at the moment, because it's process cooling, it's not applying. And is there in future something planned?
Thanks for the question. The brief reply is no. Basically, we made some reasoning throughout the process if the regulation should have been not only at product level, but also at system level on data centers, but also for reasons, like my colleague Svet said, we finally decided to go at product level. It's also legally difficult to enforce something at system level. Let me also complement by saying that actually several of the appliances in a data center for providing cold, like I could imagine a process chiller or an air conditioning chiller or a ventilation unit, are already covered by eco-design. But the data center as system per se is not covered and will not likely to be covered by eco-design in the next upcoming years.
Thank you very much, and enjoy the rest of the day. I don't think the program is finished anyway, so see you later.
Thank you.
Thank you.